The story of the Firebrand fighter starts back in March 1939. That is when the British Admiralty decided the fleet urgently needed a new two-seat carrier-based fighter interceptor. The Navy was essentially looking at two different concepts. One aircraft would have standard fixed forward firing guns. The other would feature guns in a power-operated turret. This was just like they had already done on the Blackburn Rock. These new aircraft were being developed as a modern replacement for the aging Blackburn Rock and Ferry Fulmar. But the very first real dogfights of World War II clearly demonstrated a harsh reality. Turret-armed fighters were completely defenseless against the fast German Bf-109s. Because of this, the turret fighter concept was quickly and permanently scrapped. The requirements for the fixed gun design were later revised. The goal was to squeeze the maximum possible flight performance out of it. As a result of these changes, Ferry created its famous Firefly carrier fighter. But Blackburn's initial project remained on the drawing board as just a few rough sketches. Preoccupied with developing unorthodox and underperforming aircraft like the Fulmar and the Rock, the Royal Navy completely lost sight of the need for conventional single-seat carrier fighters. The Admiralty finally seemed to wake up only when full-scale naval warfare broke out. They suddenly realized that the most modern fighter on His Majesty's aircraft carriers was the hopelessly outdated Gloucester C Gladiator biplane. The situation at sea became borderline critical, since the massive two-seat Firefly inherently lacked high maneuverability and speed. The Navy urgently needed a proper single-seat interceptor. Engineers at Hawker took on the development of the new aircraft. They worked alongside Blackburn, a company eager to redeem itself for its earlier failures. The more prestigious manufacturer Supermarine did not participate in the competition. All their manpower and resources were tied up with perfecting the legendary Spitfire. By July 1940, Blackburn's chief designer George Edward Petty had already prepared a detailed preliminary design for the new fighter. He then presented it to Naval Command for review. To be frank, Petty's design looked highly unusual for its time. It was a truly massive aircraft with a wingspan of almost 50 feet. It also packed a heavy 4-cannon armament. In terms of size, this airframe dwarfed not just every carrier fighter of the era, it was even larger than some bombers and torpedo planes. Obviously, this bulkiness was the result of the designer simply reworking his older two-seat concept. He was just adapting it to the new requirements. For this absolute behemoth to not just get off the carrier deck, but actually carry out combat missions effectively, it needed the right engine. In theory, the Bristol Centaurus radial engine was a perfect fit for the job. However, the aviation authorities at the time had a strong bias against using air-cooled engines on fighters. Because of this stubbornness, they had to install a liquid-cooled Sabre 3 engine in the aircraft. This massive 24-cylinder power plant from Napier cranked out an impressive 2,337 horsepower. It drove a huge 3-bladed de Havilland propeller with a whopping 14-foot diameter. Yet even with that colossal amount of power under the cowling, the aircraft did not promise any record-breaking speeds. But despite all the compromises, it was still a much better option than the outdated Sea Gladiator, Skua, or even the Hurricane. So the Navy gave the green light. Blackburn received an official order to build the first prototypes and 50 production airframes. Production of these giants kicked off at the factory in the English town of Brue. The first prototype was completed by February 1942. The design of this aircraft is so fascinating that it is definitely worth taking a closer look. Picture these dimensions. The aircraft length was 38 feet and 9 inches. The height reached 13 feet and 3 inches. The wingspan was exactly 50 feet. Tucked away in the nose of the fuselage sat that same powerful Sabre 3 engine. The fuselage itself was built around a solid welded steel tube framework. The engineers neatly enclosed the engine in a cowling. They also cleverly hid the cooling radiators right in the wing roots. To make life easier for mechanics working on the engine out in the field, the cowling was designed with large, quick-release panels. These panels could be removed in a flash. Right behind the engine, engineers placed the main and auxiliary fuel tanks. This layout pushed the cockpit even further back. Because of this design, the pilot sat much closer to the tail than to the nose of the aircraft. This choice drew a lot of justified criticism right from the start. That long nose severely blocked the forward visibility of the pilot. Good visibility was something absolutely critical in a dogfight and on approach to land. Behind the cockpit, the fuselage transitioned into an oval shape with a semi-monocoque design. This meant the aircraft skin bore some of the structural load in flight. And all the way in the back, as you would expect from a true carrier-based fighter, an arrestor hook was installed for deck landings. The vertical stabilizer had a rather unusual shape for British aviation of the time. It looked like a trapezoid. To prevent the airflow from blanking the elevator, the designers shifted the horizontal tail slightly forward. This design choice actually went on to become a signature feature of Blackburn aircraft. On top of that, to counter the massive torque from the propeller, the vertical fin was intentionally offset to the right. Aside from its massive wingspan, the wing stood out thanks to its extremely large hydraulically operated Fowler flaps. These flaps started right at the wing roots and stretched all the way out to mid-span. In most other respects, the wing design was fairly conventional. It featured a sturdy center section that housed the massive landing gear struts. This was paired with the outer wing panels. The entire trailing edge was taken up by those Fowler flaps and the ailerons. The engineers intended for the wings to house 4 powerful 20mm Hispano cannons. Each cannon had an ammo capacity of 200 rounds. However, this armament had not been installed on the first prototype just yet. Since the aircraft was meant for carriers, its wings folded manually. They swung backward, pivoting so the leading edges pointed straight up. This allowed the fighter to fit inside a cramped carrier hangar. At the end of February came the moment of truth. It was time to see if the B-37 could take to the skies at all. Because the main factory airfield in Bruges was flooded at the time, the aircraft had to be moved over to another base, Le Confield. It was from there, on February 27th, that the aircraft made its maiden flight. Flight Lieutenant Arthur Thompson was at the controls. Surprisingly enough, both this initial flight and all the subsequent ones went incredibly smoothly. So after some minor tweaks to the tail section, the prototype was sent off to Boscombe Down in June 1942. This relocation was done for more rigorous weapons testing. But this is exactly where things went completely sideways. Initial flight tests showed that the aircraft was, to put it mildly, completely unfit for the fighter role. The airplane pulled so hard to the right that carrier deck operations were completely out of the question. The elevator suffered from constant buffeting. The aircraft had terrible stability, and at high speeds, directional control became practically impossible. The rudder flat out locked up. Aileron control forces were incredibly heavy, requiring massive physical effort from the pilot. This was an absolute deal-breaker for a highly maneuverable fighter. On top of that, the aircraft had a nasty habit of swerving unpredictably during the landing rollout. And as if that wasn't enough, thanks to the overly long engine cowling and poor cockpit placement, the pilot had almost zero forward visibility when on approach. The disastrous prototype was sent back to the factory for a major redesign. But the first attempt achieved absolutely nothing. The airplane was just as hard to fly as before, so the prototype went right back to the engineering team. It didn't make its third appearance at the test facility until December of that year. This time, the engineers did a much deeper rework. They completely swapped out the ailerons, the vertical stabilizer, the rudder, the elevator, and even the cockpit canopy. They also added an extra set of split flaps to the wings, mounting them directly beneath the main ones. After all this trial and error, the test pilots finally noticed a major improvement in handling. But it was still nowhere near perfect, so the fight to keep the project alive pressed on. The engineers increased the area of the vertical stabilizer and rudder even more. They also swapped the concave profile of the elevator for a completely flat one. That actually did the trick. The aircraft became much more responsive, and it finally stopped pulling so hard to the right. But of course, new problems cropped up. Thanks to an asymmetrical rudder, making a right turn took serious physical effort. And at low speeds, the pilot had to constantly fight to keep the wings level. The ailerons were easier to move now, but they no longer returned to neutral on their own. And deploying the flaps meant the pilot had to aggressively trim the aircraft. Plus, the flaps themselves caused severe aerodynamic buffeting throughout the entire airframe. In March 1943, the long-suffering aircraft arrived back at RAF Boscombe Down to get an entirely new rudder. With this new tail assembly installed, the prototype actually became fairly comfortable to fly at indicated airspeeds up to 345 miles per hour. And to eliminate that severe buffeting on landing, they went ahead and perforated those extra lower flaps. punching holes in them so the air could flow right through. In May, the first experimental prototype was shipped off to the Napier Flight Test Facility in Luton. The engineers there were tasked with completely overhauling its power plant. The Air Ministry laid out a clear goal: equip the Firebrand with a modular engine installation, just like the power egg concept used on the German Junkers Ju-88 bombers. The whole idea was to integrate the engine, cowling, cooling radiators, and all the engine mounts into a single, self-contained unit. This would let ground crews swap out a damaged engine as quickly and painlessly as possible, right out in the field. It sounded great on paper, but in practice, they only managed to build 5 of these experimental units based on the Napier Sabre engine. Ultimately, this complex setup never actually made it into full-scale production. The next prototype was a fully capable combat aircraft. It was equipped with heavy firepower. It had 4 Hispano cannons and underwing hardpoints capable of carrying 500-pound bombs. This version made its first flight in mid-July 1942. By the fall, the aircraft was delivered to the Royal Navy. In early 1943, the most critical phase began. This was testing on the flight decks of actual aircraft carriers like HMS Illustrious and HMS Implacable. At the controls was an experienced pilot, Commander Dennis Royal Farquharson Campbell. It is worth mentioning that landing the Firebrand on a carrier was not for the faint of heart. The aircraft was so massive and its approach speed was so high. Many had the terrifying thought that the arresting wire simply would not hold. They feared it would snap or be torn completely out of the deck. Fortunately, disaster was avoided, but the trials revealed other serious flaws. Besides the frankly terrible visibility from the cockpit, the wing folding mechanism became a real headache. Out on the open flight deck, fighting strong crosswinds, it took an entire crew of deckhands to manually fold the wings. After finishing sea trials, this specific aircraft was sent back to the Blackburn factory for further upgrades. That is where it ran into serious trouble. In late February 1943, test pilot Arthur Thompson took the aircraft up for another test flight. Suddenly, a critical failure occurred. An oil line ruptured. The engine seized instantly. A thick layer of hot oil coated the windscreen, completely blinding the pilot. Attempting a blind emergency landing, Thompson did not spot a major hazard. The aircraft was traveling at high speed. It smashed into a 1.5-inch steel cable of an aerial tramway. This was at a cement plant just 1 mile short of the runway. This unseen cable acted like a makeshift carrier arresting wire. It brought the multi-ton aircraft to a dead stop in mid-air. Then it snapped with a loud crack. It whipped back and slammed into the fuselage right behind the cockpit with incredible force. Incredibly, flight controls were not completely lost. In a miraculous piece of airmanship, Thompson managed to limp the battered aircraft back to the airfield for a safe landing. The pilot walked away without a single scratch, but the aircraft itself looked ready for the scrap heap. At first, they wanted to write it off for good. However, the engineers managed to rebuild the airframe. They extensively redesigned its structure. Eventually, this specific aircraft became the prototype for an entirely new variant. In May 1943, the B-37 project finally received its official service name, the Firebrand. But right at that moment, the chances of this formidable aircraft actually entering service with the Fleet Air Arm became highly uncertain. The problem was that the development of the Firebrand had suffered heavy delays. During this time, the Royal Navy had already deployed navalized Sea Hurricanes. They also successfully tested the carrier-based version of the legendary Spitfire, the Seafire. When evaluators compared their flight characteristics, the results were clear. It turned out that the new, compact Seafire was vastly superior to the sluggish giant built by Blackburn. During mock dogfights, it became obvious. As a classic fighter, the Firebrand was woefully inadequate. It could really only boast an advantage in dive speed. In a tight, maneuvering dogfight, it was hopelessly outclassed by its rivals. This was despite having almost the same top speed. As a result, the Firebrand found itself on the verge of obsolescence before it even entered service. Making matters worse, the Ministry of Aircraft Production made a tough decision. They decided to divert the entire supply of Napier Sabre engines. These were sent to the production of the much-needed land-based Hawker Typhoon ground attack aircraft. Because of this, the B-37 project was at risk of being left without a power plant entirely. Meanwhile, assembly of the first production batches of the Firebrand was already in full swing at Blackburn's factories. The assembly lines were rolling, and they urgently needed to figure out what to do with the finished airframes. Mock dogfights had definitively proven that the aircraft was completely useless as a light maneuverable fighter. You would think this ambitious project would meet an unceremonious end right then and there. But fate had an unexpected twist in store for the aircraft. During World War II, Great Britain was suffering from a severe shortage. They lacked not just carrier-based fighters, but effective torpedo bombers as well. The primary aircraft tasked with these missions were the Fairey Swordfish, along with its intended successor, the Albacore. Both of these were obsolete biplanes. Their top speed barely cracked 155 miles an hour. Meanwhile, the Fairey Barracuda was just entering fleet service, but it performed more like a dive bomber than a dedicated torpedo bomber. Since the new Firebrand had a pretty substantial payload capacity, Blackburn pitched an interesting solution. They proposed to convert it into a single-seat torpedo bomber. The idea of a single-seat torpedo bomber was not exactly a brand new concept. The very first aircraft in this class, like the Sopwith Cuckoo, were flown by a single pilot. And the last aircraft of its kind, the Dart, was actually developed by Blackburn themselves. However, the concept had evolved quite a bit since then. The plan was for the Firebrand to become a sort of carrier-based equivalent to the heavy-hitting Bristol Beaufighter. It would not just attack enemy ships with a heavy torpedo, rockets, or cannon fire. If needed, the aircraft had to be capable of holding its own in a dogfight against enemy bombers and seaplanes. And once again, Blackburn's engineers had the most experience developing these kinds of versatile aircraft. Their Skua dive bomber had already proven surprisingly successful as a fighter early in the war. As a result, the Firebrand was slated to transform from a standard fighter into a formidable torpedo fighter. With the aircraft's new role finally hammered out, they still had to address its power plant. The only real alternative to the Sabre engine in Britain at the time was the Bristol Centaurus. They had previously passed over this option. But things had changed. The British military had learned the hard way that a fighter equipped with an air-cooled radial engine could be an incredibly lethal weapon. The German FW190 was a prime example of this. Because of this, attitudes toward the Centaurus engine improved dramatically. And that is exactly what they decided to install in the revamped Firebrand. In practice, though, making such a massive change took time. Engineers decided to roll out the updates gradually. This depended on where the airframes were on the assembly line. The first 9 aircraft were already practically finished, so they did not bother reworking them. They were kept in their original configuration. The next 2 airframes were rushed into conversion to serve as prototypes for the new Centaurus engines. Another 11 aircraft retained the old Sabre engines, but they were designated as a transitional model. It was only the subsequent aircraft rolling off the line that were factory-equipped with the powerful new Centaurus engines right out of the gate. Naturally, those first 9 original spec aircraft never saw frontline service. Instead of flying combat missions, they became testbeds for various experiments conducted by Napier. They were also used by the testing centers at the Royal Aircraft Establishment in Farnborough. These aircraft were flown incredibly hard. They were pushed to the absolute limits of their flight envelopes. Of course, this aggressive testing led to its fair share of crashes. Fortunately, none were fatal. In fact, these accidents proved highly valuable. They helped engineers quickly track down and iron out hidden design flaws. The first major incident involving a production Firebrand happened during service trials evaluating its build quality and combat readiness. On September 23, 1943, Lieutenant Albert Gilbert took the aircraft up for a routine test flight. Gilbert served with the Free French Naval Air Arm, but was temporarily assigned to the British as a test pilot. As the fighter climbed to 24,000 feet, it suffered a catastrophic failure. A connecting rod let go and punched right through the engine crankcase. It was a critical emergency, but Gilbert kept his cool. He managed to throttle the damaged engine back to idle and carefully started gliding back toward his home field. However, during his approach, he had to add a little power. When he did, the blown engine spewed hot oil all over the windshield. Gilbert was forced to land completely blind. The resulting hard landing collapsed the gear, and the airframe was written off. Despite totaling the aircraft, the lieutenant received an official commendation for his efforts to save it. Flight testing was temporarily halted after the crash. At that point, the airframe had logged 80 flight hours. Despite the accident, overall impressions of the design remained overwhelmingly positive. Maintenance also proved surprisingly straightforward for ground crews. Setting aside the catastrophic engine failure, the only other major issues were the consecutive failures of 3 engine control levers. This was likely just due to a manufacturing defect. Engineers also determined the gear doors were not robust enough for the punishing environment of carrier ops. But in every other respect, the new Firebrand was proving highly successful and practically free of serious design flaws. In November 1943, one of the test airframes was sent out to evaluate new weapons and radio equipment. But this particular aircraft was plagued by bad luck. For instance, on November 7th, Lieutenant David Robertson of the Royal Naval Volunteer Reserve was taxiing out for its first flight. Suddenly, the landing gear collapsed. Engineers later traced the problem to the complex hydraulic system. A pressure drop had essentially tricked the mechanism into retracting the gear. They tweaked the hydraulics, but disaster struck again on January 29, 1944. While using the aircraft for ground-based rocket firing tests at Schruten, the powerful rocket exhaust severely damaged the tail section. The bad luck streak for this airframe continued on March 7th. Squadron leader Harry Fowler was taxiing out for a weapons test flight when the landing gear failed yet again. This time, the culprit was a tiny component. A retaining ring snapped and a locking pin fell out. The heavy fighter dropped right onto its belly. The rest of the Firebrand F-1s lived fairly unremarkable lives. By the end of 1944, they were quietly sent to the scrapyard. During World War II, Great Britain was dealing with a severe shortage of not only modern carrier-based fighters, but also effective torpedo bombers. The primary aircraft for the job was the Fairey Swordfish, along with its successor, the Albacore. Both were essentially outdated biplanes. Their top speed barely hit 155 miles per hour. And the new Barracuda, which had just started reaching combat units, was by design more of a dive bomber. In this tough situation, Blackburn decided to salvage its Firebrand project. Since the aircraft had failed as a pure fighter but still had a solid payload capacity, the engineers proposed a new role. They decided to turn it into a heavy-hitting, single-seat torpedo bomber. The concept of a single-seat torpedo bomber wasn't exactly new. Even the earliest aircraft in this class, like the Sopwith Cuckoo, were designed for a single pilot. In fact, the last project of its kind, the Dart, was actually developed by Blackburn themselves. But this time, the concept was a bit different. The updated Firebrand was supposed to be a naval equivalent to the famous Bristol Beaufighter. It was expected not only to strike enemy ships with a heavy torpedo, rockets, and its cannons. It also had to hold its own in air-to-air combat against enemy bombers or seaplanes if the need arose. And here, Blackburn had an edge. Their Skua dive bomber already had a solid track record pulling double duty as a fighter. Ultimately, instead of being a traditional fighter, the Firebrand was going to evolve into a versatile torpedo strike fighter. To build a prototype for this new variant, the engineers took a pretty unconventional approach. They decided to use whatever was left of an earlier prototype. This aircraft had crashed back on February 20th, 1943. The salvaged wreckage was carefully rebuilt and upgraded. This resurrected aircraft was then given a brand new designation, the Firebrand TF2. Naturally, the design of this rebuilt aircraft had to be heavily modified. This was necessary so it could carry its main weapon, a heavy aerial torpedo. To make that happen, they widened the wing center section by 15.5 inches. They also mounted a heavy-duty centerline hardpoint to carry the torpedo itself. In this updated configuration, the modified aircraft took to the skies for the first time on March 31, 1943. After just 2 days of testing, the aircraft successfully proved it had no trouble taking off with that heavy torpedo. And on April 3rd, fully loaded with combat ordnance, the aircraft was proudly demonstrated to the Minister of Aircraft Production, Sir Stafford Cripps. In July, full-scale testing of the torpedo mount kicked off at the Boscombe Down testing facility. However, the designer's optimism quickly faded. After just 4 hours of test flights, the program had to be abruptly halted. The culprit was a dangerous vibration. It started shaking the entire airframe at speeds over 195 miles per hour. On top of that, these flights made it painfully clear that the aircraft's old handling issues were still present. The designers were going to have to go back to the drawing board to fix them. By September, testing had resumed. Thanks to new fairings on the hardpoints, the dangerous vibration was almost completely gone. Now, the aircraft only started to shake during a steep dive when the speed exceeded 330 knots. Interestingly enough, the aircraft's handling remained practically unchanged. This was true even with that heavy torpedo and its MAT-4 stabilizer slung underneath. Compared to the earlier F1 variant, the top speed only dropped by 8 knots. It went from 310 down to 302 knots at 18,000 feet. The rate of climb at sea level also dipped slightly from 2,250 to 1,900 feet per minute. Takeoff roll, however, into a 20-knot headwind increased from 515 to 680 feet. Meanwhile, the Ministry of Aircraft Production was putting pressure on the engineers. They pushed them to clear the aircraft for live torpedo drop tests as quickly as possible. But the Flight Test Center flat out demanded more time to track down and fix all the underlying handling quirks. After all, the original flaws had not gone away. For instance, the aircraft still had a nasty habit of departing controlled flight during steep turns. On top of that, the airplane's stability across all 3 axes was rated as completely unacceptable. This was much like the abysmal visibility from the cockpit. Engineers determined that the oversized flaps were the main culprit behind this instability. The best fix would have been swapping them out for short-span slotted flaps. Unfortunately, at that stage of development, implementing a modification of that scale without a complete airframe redesign was practically impossible. So the engineering team decided to iron out the aircraft's flaws incrementally. And, as time would tell, this decision turned out to be disastrous. Based on the test results, the second variant of the aircraft was declared completely unfit for combat operations. They cleared it only for experimental test flights, and even then, strictly in the hands of the most experienced test pilots. The designers were planning to make some major structural changes down the line. Specifically, they wanted to eliminate the turtle deck from the rear fuselage, which was only hindering maneuverability. They also planned to install spring-loaded trim tabs on all the control surfaces to try and reduce the heavy stick forces on the pilot. But the biggest problem was something else entirely. All those powerful Sabre engines were being diverted en masse to Hawker Typhoon production lines. This left the Bristol Centaurus as the only available power plant for the Firebrand. This was an engine they had actually rejected earlier because of its radial design. Times had changed, though. The British had learned the hard way that a radial engine fighter could be an incredibly lethal weapon. The German FW190 was a prime example of this. So attitudes toward the Bristol Centaurus improved dramatically, and they decided to adapt it for the new torpedo bomber. The official green light for this engine swap was given on October 3, 1943. To test the new Centaurus engine, they selected the 10th and 11th production F Mark I airframes. However, integrating this power plant into the Firebrand's complex airframe was going to take a lot of time. Because of this, they decided to finish the next batch of 12 aircraft as the second variant with the older Sabre engines. These aircraft were already on the assembly line at the Brew facility. All of these stopgap aircraft successfully rolled off the assembly line over the course of 1944. This sense of urgency was pretty simple to explain. The war was in full swing, and the Royal Navy still did not have a single high-speed strike aircraft. At that point, the Firebrand prototypes had been flying for about 2 years, and there was still no end in sight to the endless tweaks and modifications. The design team managed to convince the Admiralty that all these teething problems would disappear on the new Centaurus-powered aircraft. They promised to push it into full-rate production very soon. Navy officials bought into the hype, but they laid down a strict condition. Production at the plant could not stop for a single day. When the engineers pushed back, warning that the aircraft was still far too unrefined for safe operation, the Navy top brass simply ignored them. They flat out ordered the Firebrand TF Mark II variant to be declared fully operational from land-based airfields. As a result, Blackburn was given a clear objective. While the new Centaurus-powered Firebrand TF Mark III was being developed and tested, they had to keep supplying the older models to the fleet without interruption. These early airframes were meant for further testing. Most importantly, they were meant for fast-tracking pilot training for future combat squadrons. The first TF Mark IIs ended up at the Air Torpedo Development Unit down in Gosport. That is where British pilots got a feel for the new aircraft and hammered out the tactics for using it as a torpedo bomber. Of course, accidents were bound to happen. For example, on April 22nd, pilot John Robert Toogood belly landed his production Firebrand simply because he forgot to drop the gear. The airframe had to be written off, and Toogood caught a severe reprimand in his logbook for negligence. Exactly 4 months later, on August 22nd, another Firebrand came down at that exact same airfield with the gear up. But this time, the pilot, Leonard Richard Lord, unlike his colleague, was highly commended by his COS. The thing is, Lord's Firebrand had suffered a total hydraulic failure. He physically could not lower the gear or the flaps, and he could not even jettison the heavy live torpedo hanging right on the center line. Despite the massive risk, Lord managed to belly it in, essentially using the torpedo as an improvised skid. He pulled it off brilliantly, and the airframe itself took only minimal damage. The brass at the Ministry of Aircraft Production demanded that the Firebrand be pushed out to combat units as fast as possible. So they took the available production airframes and stood up a special testing detachment called the Firebrand Tactical Trials Unit. That is where frontline pilots continued getting the hang of the new torpedo bomber. At first, the unit was based at Lee on Solent, but in the fall of 1944, it was reorganized into 708 Naval Air Squadron. Because of this, these aircraft technically did see formal service in World War II. Why just formal? Well, because the squadron was a second-line unit and never saw any actual combat. Overall, Navy pilots gave the new aircraft a pretty warm reception, even though a chronic shortage of spare parts really put a damper on things. After a brief stint in service, these early models were simply sent off to the scrapyard. That marked the end of the line for the Sabre-powered variants. They were replaced by the slightly more successful versions sporting the Centaurus engines. Only one question remained. Why waste so much precious time developing the airframe around the Napier Sabre in the first place, when they could have just used the more powerful Centaurus right from the start? I guess that is just classic British conservatism at work. And as it turned out later on, this was just the beginning of their troubles. Once the debate over whether the aircraft was even needed seemed settled, they still had to deal with its heart. That was the engine. Back in 1942, the Ministry of Aircraft Production decided to divert all available Napier Sabre engines. They were sent to the production lines of the Hawker Typhoon land-based fighters. These fighters were in much higher demand. Because of this, the B-37 torpedo bomber was in real danger of being left without an engine altogether. At the time, the only viable alternative in the UK was the Bristol Centaurus radial engine. They had actually rejected this engine earlier, but the British had learned the hard way. A fighter with an air-cooled radial could be an incredibly formidable weapon. The prime example of this was the German Focke-Wulf FW-190. After facing it in combat, their attitude toward the Centaurus completely changed. They finally decided to fit it to the British torpedo bomber. By the way, speaking of the FW-190, it was also supposed to become a torpedo bomber in one of its variants. But that specific version never actually made it into full-scale production. Swapping out the engine was a step in the right direction, but even that move had its critics. The issue was that the Centaurus 7 offered a bit more power and excellent reliability. However, it also had a massive frontal area. This created a lot of drag. It was perfectly logical to assume that the pilot's forward visibility would get even worse. It was already notoriously poor. Add the less-than-ideal low-speed handling to the mix, and it became obvious. Safely landing this kind of Firebrand on a carrier deck would be practically impossible. That is exactly why there were calls to stop wasting time endlessly modifying the airframe. Instead, some proposed designing a completely new aircraft from scratch. It was supposed to be built from the ground up around the Centaurus engine. It would also feature a shorter wingspan. In theory, British industry still had time to get this new aircraft into mass production before the war ended. It was sort of a hybrid between the Sea Fury and the Sky Raider. Design work on the new B-48 strike fighter actually began back in 1943. However, the Ministry of Aircraft Production insisted on focusing all efforts on refining the Firebrand. The Royal Navy desperately needed new torpedo bombers. There simply was no time left to develop an airplane from scratch. Government officials were well aware of how long aircraft development typically took in Britain. While knowing this, none of the top ministry bureaucrats could have predicted one thing. They did not expect just how long the process of ironing out the bugs on the Firebrand would actually drag on. On October 3, 1943, Blackburn received official orders to update the Firebrand. They were to fit it with the more powerful Centaurus engine. For this experiment, they pulled 2 production aircraft straight off the assembly line. These were the older Firebrand F-1 variants. Because of the massive number of changes, these airplanes received a new operational designation, This was the Firebrand TF3. They also received a new internal company designation, B45. This clearly highlighted the scale of the work that was done. The most obvious difference between the Mark III and earlier variants was the entirely redesigned nose section. The old engine was swapped out for a massive 18-cylinder Bristol Centaurus 7. This powerhouse cranked out an impressive 2,430 horsepower. It spun a huge 4-blade Rotor propeller that measured 13 feet 3 inches in diameter. To make the aircraft more maneuverable and improve pilot visibility, designers removed the bulky turtle deck behind the cockpit. They also planned to install a clear bubble canopy. Even so, the engineers were well aware that forward visibility would still be poor, so they took an unconventional approach. To allow the pilot to keep their eyes outside on the carrier deck during a landing approach, they needed a way to avoid looking down into the cockpit. Because of this, the most critical instrument, the airspeed indicator, was duplicated outside the aircraft. It was tucked under a small fairing. This was absolutely vital. The landing speed of the Firebrand was right around 80 knots, which was dangerously close to an aerodynamic stall. The wing was left largely unchanged from the earlier Firebrand F Mark II model. The only major difference was the replacement of the old radiators in the wing roots. Now they featured a carburetor intake on the left side and an oil cooler on the right. While adapting the airframe for the heavy new Centaurus engine went relatively smoothly, the battle against the inherent flaws of the aircraft was still ongoing. Poor handling remained its biggest issue. To try and make life at least a little easier for the pilots and reduce the heavy stick forces, engineers made several changes. They rigged all control surfaces with spring tabs. They also increased the surface area of the rudder and widened the span of the horizontal stabilizer. Company representatives genuinely believed that these modifications would cure the Firebrand of its instability once and for all. They were convinced the Mark III would finally become a capable combat aircraft. By some miracle, this confidence rubbed off on Air Ministry officials. They immediately ordered 12 Firebrand TF Mark II aircraft. They planned to use them as trainers to prepare the pilots who would eventually fly the new Mark IIIs. That proved to be incredibly naive. On December 21, 1943, the first prototype of this upgraded variant made its maiden flight. By March of the following year, the initial phase of flight testing had concluded. Blackburn was eager to get an official verdict from the independent military test pilots at the Aeroplane and Armament Experimental Establishment. They just wanted to see if all these endless design changes had actually paid off. The pilot feedback was generally positive, but the main problem remained. The handling of the airplane was still marginal at best. With flight characteristics like that, safe operations from a cramped carrier deck were totally out of the question. The company now pinned all its hopes on the second Mark III prototype. This aircraft was significantly different from its not-so-successful predecessor. The most noticeable feature was the new clear sliding bubble canopy. It also featured a slightly raised pilot seat for better visibility. On the first prototype, they had retained the original greenhouse canopy, only cutting down part of the rear fuselage. Plus, the engineers slightly offset the vertical stabilizer from the center line of the aircraft. This was done to compensate for the dangerous yaw caused by engine torque during takeoff. On top of all that, the airplane was fitted with improved elevators and ailerons. These were supposed to finally tame its unruly flight characteristics. Since the Mark III was meant to be a dedicated torpedo bomber, it was equipped with a special 2-position torpedo rack. It worked cleverly. When the landing gear was down, the torpedo was angled down at 6 degrees relative to the fuselage. But as soon as the gear retracted after takeoff, it pivoted to sit parallel to the belly. Thanks to this clever design, the aircraft maintained plenty of ground clearance with a torpedo slung underneath. At the same time, it minimized aerodynamic drag in flight. In April, the second prototype began its initial test flights. Overall, the updated design impressed the pilots. The aircraft had become much more responsive on the controls. However, the new vertical stabilizer proved to be a disappointment. Directional stability remained a serious issue. In August 1944, the designers tried to resolve the problem using an asymmetrical flap deployment. But that had no effect whatsoever. It became glaringly obvious. The Firebrand desperately needed a completely new vertical stabilizer. The engineers had to act fast. They fitted the first aircraft of the third variant with an updated rudder mechanism. This included a split trim tab and a spring tab. This upgraded version was put through its paces at the Boscombe Down Research Facility. And even though it performed significantly better during flight testing, it still was not a complete solution to all of the aircraft's problems. Ultimately, they decided to equip the second prototype with a new, much larger vertical stabilizer. They also added a horn-balanced rudder. Thanks to this modification, they finally managed to resolve the handling issue. But unfortunately, the overall stability of the aircraft still left a lot to be desired. Meanwhile, over at the factory in Brau, production was in full swing. They were working on a batch of 50 Firebrands that had been ordered at the very beginning of the war. Some of these aircraft rolled off the line as the baseline F1 model. A few others were converted into prototypes for the TF3 variant. Later on, 10 aircraft were completed as the TF2 version. Only the remaining 27 were finally fitted with the powerful Centaurus engines. But strangely enough, plant management decided not to halt the assembly line. As a result, these production aircraft missed out on all the crucial upgrades. These upgrades had already been successfully tested on the prototypes. For example, they retained the original unmodified tail section. The first of these 27 production aircraft from the third variant made its maiden flight. This took place from the factory airfield in early November 1944. At the controls was the company chief test pilot, Group Captain Charles Flood. And by May of the following year, the final TF3 airframe had left the assembly line. Interestingly, the last 17 aircraft of this production run received a brand new, much more powerful Bristol Centaurus 9 engine. It produced an impressive 2,520 horsepower. On top of that, the engine mounts were equipped with modern vibration dampers. This provided a much smoother ride for the pilot. Compared to the older models flying with Sabre engines, these new aircraft suffered a slight reduction in top speed and range. However, they were far more maneuverable. They also boasted a significantly better rate of climb. Unfortunately, the new Firebrand had some serious flaws too. The biggest issue was the abysmal forward visibility during landing. Pilots had to adapt by flying their final approach in a steep, continuous turn. This was done just to keep the runway in sight. Furthermore, the aircraft completely lost its directional stability the moment the pilot lowered the flaps. For a carrier-based aircraft, that was absolutely unacceptable. As a result, this third variant was deemed unfit for real combat operations. Instead, that role would fall to the subsequent version. This was the TF4, which became the first fully capable combat aircraft in the lineup. So rather than deploying them to frontline squadrons, these new aircraft were relegated strictly to pilot training and experimental testing. For example, in February 1945, a few production aircraft from the third variant were sent over to Farnborough. They were sent there for rigorous testing, specifically simulating carrier landings. Shortly after, another airframe was brought in to join the testing program. These high-risk flights were flown by legendary test pilot Eric Brown. He started his initial familiarization flights in March, eventually ferrying the aircraft to Henstridge Airfield. There, the practice landings began. One of those attempts almost ended in disaster when the aircraft's tail hook sheared completely off during touchdown. This kind of situation was nothing new for Eric Brown. 6 months earlier, at that exact same spot, he had run into the exact same problem while flying the first variant, the TF1. These tests proved one thing beyond a doubt. The Firebrand was totally unforgiving of pilot error. If you drifted off the center line by even 20 feet, the landing turned into a fatal gamble. In the end, the only real achievement for the third variant of the Firebrand was the successful testing of rocket-assisted takeoff gear. Interestingly, even if one of those rockets suddenly failed, the aircraft stayed completely stable. It also remained easy to control. On the downside, 2 lost aircraft quickly had to be written off as total losses. The first incident happened on February 7, 1945. The pilot, Lieutenant Commander Torrens Spence, took off from Gosport Airfield to test a special torpedo mount. During a steep dive from 13,000 feet, the aircraft dropped through 6,000 feet and hit 426 miles per hour. At that moment, the torpedo's stabilizer fin suddenly tore off. At that high speed, the part slammed right into the tail section of the aircraft. The damage was so severe that controlling the aircraft at speeds below 288 miles per hour became practically impossible. Realizing this, the pilot made the only viable choice. He decided to bail out. Just 9 days later, another Firebrand was lost. On this particular airframe, engineers had slightly modified the design of the elevator trim tabs. That was exactly what led to fatal consequences. During a dive, these parts induced such severe flutter that the entire tail section eventually tore completely off in midair. The pilot, squadron leader James Tobin, was violently thrown from the cockpit. But the worst happened. His parachute snagged on the wreckage of the falling aircraft. The canopy tore open, and the pilot tragically died upon impact with the ground. Overall, it is safe to say that putting the third variant into full-rate production was simply a waste of precious time and resources. After all, within the next few years, every single one of these airframes was struck from the register and scrapped. On May 17, 1945, the milestone Naval Command had been anticipating for years finally happened. The first truly combat-ready Firebrand took to the skies. It was the first airframe from a massive order of 250 aircraft. At the time, it was believed to be the fully finalized Mark IV variant of the aircraft. Compared to the previous, purely experimental model, the new Mark IV featured a larger tail surface area. The vertical stabilizer was offset by 3 degrees to compensate for engine torque. Dedicated dive brakes were also installed on the wings. The heart of the aircraft was the powerful Bristol Centaurus 9 engine. It was mounted on a specialized frame with vibration isolators, which made the flight significantly smoother. Since the aircraft was built for carrier operations, it was equipped with heavy-duty attachment points for carrier catapults. It also featured mounts for rocket-assisted takeoff gear. On top of that, you could sling a massive arsenal under this aircraft. It could carry a heavy torpedo or a 2,000-pound bomb on the center line. It could also carry 500-pounders under each wing, along with 6 60-pound rockets. Some sources claim the payload could be pushed even further. It could carry a pair of 1,000-pound bombs or up to 16 rockets. For ferry flights or longer missions, they could swap the ordnance for drop tanks. This included a 100-gallon tank on the center line or 2 45-gallon tanks under the wings. Fully loaded, the aircraft's max takeoff weight hit an impressive 16,700 pounds. The first completed airframes were immediately sent off to British test centers. Flight trials kicked off to see if the new Firebrand could actually meet the strict demands of carrier operations. Engineers and pilots rigorously evaluated catapult launches. They also tested carrier landings using the arresting wires. And all of these demanding maneuvers were flown with various heavy weapon loads hung on the hardpoints. But the test results were far from impressive. When the second prototype of the Mark IV arrived for evaluation in the summer of 1945, test pilots declared it completely unfit for combat. The main culprit was a set of overly complicated counterweights in the elevator control system. Designers had installed them hoping to improve pitch stability. However, the fix completely backfired. The aircraft actually became harder to handle, especially at low speeds. On top of that, the ailerons were incredibly sluggish. During steep dives, they would start shaking violently. Right up until 1946, Blackburn engineers tried desperately to iron out these flaws. They wanted to make the aileron controls more reliable, but the troubleshooting process was difficult. On one occasion, a routine test flight almost ended in disaster. On March 7, 1946, Lieutenant Peter George Lawrence took a TF Mark IV up for a test flight. He was working as a civilian test pilot for Blackburn at the time. His primary task was to evaluate the latest tweaks to the aileron control system. The engineers genuinely hoped these modifications would finally cure the dangerous shaking during steep dives, but things did not go according to plan. While he was still climbing, even before the dive began, the ailerons started vibrating. They entered a deadly aerodynamic condition known as flutter. Lawrence kept his cool and pushed the throttle forward. When the aircraft passed 20,000 feet, the severe vibrations suddenly vanished. But the relief was short-lived. Passing 25,000 feet, the flutter returned. This time it was much more violent. Just picture this. The airplane's wings were literally flexing up and down with an amplitude of almost 3 feet. Stress cracks instantly started spiderwebbing across the metal skin and the canopy glass. Lawrence quickly realized the airframe was failing. It was time to bail out. He chopped the throttle, slowing the plane down to 115 miles per hour. Then he got ready to jump. But at that exact moment, the violent shaking stopped just as suddenly as it had started. Feeling the flight controls respond again, the pilot decided to stay with the aircraft. Holding that safe airspeed, he carefully limped the crippled fighter all the way back to the Blackburn airfield at Brough. There, he managed to pull off a surprisingly smooth landing. Ultimately, after a thorough teardown and analysis of the incident, the design team made a decision. They chose to install wider-span trim tabs on the ailerons. Yet, despite all the time and effort poured into it, Blackburn never completely cured the airplane's inherent aileron issues. The problem continued to plague the Firebrand throughout its service life. While Blackburn's engineers were racking their brains over the stubborn ailerons, dive brake testing was in full swing at Farnborough. These panels were used to slow the aircraft down during a steep dive. Located on both the upper and lower surfaces of the wing, they took up nearly a third of its span. The initial test results were a major disappointment. It took the hydraulic system a full 5.3 seconds to fully deploy the brakes at 300 knots, and it took 2.2 seconds to retract them at 260 knots. But sluggish mechanisms were not the only issue. Deploying the brakes caused the aircraft to sharply pitch down, while retracting them caused it to pitch up. This was accompanied by severe buffeting and airframe vibration, especially near the wing roots. Fortunately, this time the problem was not aerodynamic. Specialists at the RAE found a brilliantly simple solution. They just removed a restrictor valve in the hydraulic system, which was located between the pump and the brake actuator. The results exceeded all expectations. The operating speed of the dive brakes nearly doubled. Now the pilot only had to retrim the aircraft when deploying them at high airspeeds. This meant speeds over 250 knots, and that severe vibration disappeared completely. In level flight, deploying the dive brakes instantly bled off about 60 knots of airspeed. The aircraft reached its terminal dive velocity in roughly a 50-degree dive. It is worth noting that the Firebrand was incredibly stable in a steep dive. It entered the maneuver smoothly without needing a trim change, and the pullout required about 5 pounds of stick force per G. As the aircraft approached its absolute maximum dive speed, a slight buffeting would kick in. For an experienced pilot, this was a clear warning sign. It meant the aircraft was nearing its red line, and it was time to bleed off some speed. Overall, the aircraft demonstrated perfectly acceptable performance, and the Firebrand easily met the strict demands of mid-40s naval aviation. This heavy fighter had so much sheer power that it could actually perform aerobatics, even with a live torpedo slung under the fuselage. Lieutenant Commander Ivers famously demonstrated this capability. This took place during an airshow at Heston on October 2, 1945. Still, for historians, one logical question remains. Why did the TF-4 variant only enter service at the tail end of World War II in 1945, rather than in 1941, when an aircraft like this was so desperately needed? In total, the Brough factory produced 102 Firebrand TF-4s. The rest of the airframes on order were upgraded and rolled out as the improved TF-5 variant. Yet despite the fairly large production run, these aircraft barely saw any time with frontline fleet units. The one major exception was a batch of 15 Firebrands, which were delivered to 813 Naval Air Squadron. This unit was commissioned on September 1, 1945, at RNAS Ford in Sussex. Over the next 2 years, the squadron's pilots put the aircraft through their paces during intensive operational trials. It is believed that some of these tests even took place on the decks of aircraft carriers. On top of that, these impressive airplanes frequently made appearances at various public events. For instance, they took part in the massive flyover above London on June 8, 1946, during the Victory Day celebrations. Unfortunately, the operational career of the fourth variant turned out to be incredibly short. By 1947, the single squadron flying them had completely transitioned to the more advanced and refined Firebrand TF-5. This relegated its predecessors to the history books for good. However, the military decided against scrapping the supposedly obsolete TF-4 airframes. Around 40 of these aircraft were later successfully upgraded to the new TF-5A production standard, since the technical differences between the two were relatively minor. In 1946, one airframe was actually sent back to the Blackburn factory specifically to serve as the lead prototype for this final variant. This became the very first aircraft to be fitted with hydraulically boosted flight controls. This system was developed in partnership with Lockheed. This new tech significantly reduced pilot workload during flight. Ultimately, these boosted controls were installed on the final 55 production TF-5As. As for the TF-4s that didn't get the upgrade, they were initially put into long-term storage before eventually being scrapped. This was despite the fact that during the design phase, the Mark IV was fully expected to be the primary combat workhorse of the entire torpedo bomber fleet. The arrival of the TF4 variant was a major turning point for the program. It proved that delivering a fully combat-ready aircraft was finally just a matter of time. Sure enough, it wasn't long before the very first production Firebrand TF5 rolled off the assembly line at the Brew factory. Fundamentally, the new aircraft was almost identical to the earlier TF4. The main difference was the revised tail section. Engineers fitted the elevator with aerodynamic extensions known as horn balances, and also enlarged the aileron trim tabs for better balance. Reverting to this design was somewhat of an act of desperation for Blackburn's engineering team. They had nearly given up on fixing the aircraft's lingering stability issues in the air. Much to their surprise, however, this tried-and-true approach proved far more effective than all their previous, overly complex aerodynamic fixes. Interestingly, this solution was actually proposed during the development of the early TF3 prototype, but it took the engineering team quite a while to finally bite the bullet and implement it. Other changes mostly came down to minor updates to the internal systems. Even though the differences between the Mark IV and Mark V were minimal, the manufacturer decided to pitch the aircraft as a completely new design with a fresh designation. Management clearly wanted to distance themselves from the earlier, underperforming variants. They wanted to market the updated Firebrand as a mature, reliable combat aircraft completely free of its initial teething problems. Unfortunately for the design team, a new designation and flashy marketing couldn't magically erase the airframe's inherent flaws. Even as late as 1949, experienced test pilots were still harshly criticizing the Mark V for being highly unstable during climbs. In the end, the Navy decided to simply accept the deficiency. There simply wasn't time left for endless tweaks and ground testing. The fleet desperately needed airframes in service. The new Mark V quietly replaced its predecessors on the assembly line. The exact number of Firebrand TF5s originally ordered by the military remains a bit murky. Some sources suggest the plan was to produce 148 of these aircraft on top of the existing contracts. But with the war in the Pacific drawing to a close, funding was severely slashed. As a result, Blackburn ultimately built just 68 units of this variant. The final aircraft rolled out of the Brow factory on March 31, 1947. Another 80 planned aircraft remained strictly on paper. However, this was far from the worst-case scenario for the manufacturer. In the post-war period, contracts for many other military aircraft were being completely canceled, leaving aviation plants idle. The reason the Air Ministry decided to keep producing the Firebrand was actually simple. At the time, the Royal Navy still didn't have a high-speed torpedo bomber or any modern aircraft in that strike class at all. So the military just had to make do with what the industry delivered. Eventually, the Firebrand was fitted with hydraulic aileron boosters. These were similar to the ones successfully tested earlier on the TF4 variant. These boosters were developed jointly by Blackburn and Lockheed. They finally helped solve the long-standing control and stability issues of the aircraft in the air. Even though the new system took on a significant chunk of the workload, flying the aircraft was still far from easy. For example, at a speed of 403 miles per hour, the pilot had to apply a whopping 50 pounds of force to the stick just to roll the fighter. Meanwhile, the actual roll rate was a mere 43 degrees per second. For comparison, that was 2.5 times slower than the German WW190. These disappointing test results at the Royal Aircraft Establishment at Farnborough proved a point once again. The whole torpedo fighter concept was fundamentally flawed and fell short of expectations. Aircraft equipped with these hydraulic boosters received a new designation, the Firebrand TF5A. In fact, this was the first version truly ready for combat operations. Initially, only 55 of these aircraft were built, but the story did not end there. Later, between 1947 and 1950, almost all surviving TF5s were upgraded to the TF5A standard. This also included about 40 of the older TF4s. Thanks to this modernization program, this specific variant became the most produced in the history of the aircraft. This brought the total number up to 105. Interestingly, it was the upgraded TF5As rather than the standard Mark Vs that eventually made it onto carrier decks. Since almost no one had ever seen a standard TF5 in the fleet, pilots and mechanics often did not make a distinction. They simply called both aircraft the Firebrand TF5. By early 1948, the top brass decided to simplify their complicated designation system. These aircraft then officially became known as the TF-5 and TF-5A. When it came to the flight characteristics of the Firebrand, legendary test pilot Eric Brown noted that they were really only suitable for land-based aircraft and absolutely not for carrier operations. There were no complaints about the Bristol Centaurus 9 engine itself. It was incredibly reliable. It usually fired right up on the first try using a Kaufman cartridge starter. However, if this trusty engine failed in flight, the chances of the pilot making a successful emergency landing dropped to near zero. Without a working engine, bringing this heavy aircraft down safely was an incredibly difficult task. This was true even on a massive land-based runway. During takeoff, the aircraft had a nasty habit of yawing hard to the right. Experienced pilots, however, could keep it on the center line with right rudder. With full flaps and takeoff power, the tail wheel would come off the runway at just 30 knots. Passing 90 knots, gentle back pressure on the stick was all it took to get airborne. As the gear came up, the nose would naturally pitch up slightly into the climb. Its best rate of climb up to 12,000 feet was at 145 knots. However, for better stability, the flight manual recommended holding a climb speed between 160 and 170 knots. Overall, the Firebrand was notoriously unstable in the climb and at slow speeds. Surprisingly, the handling actually improved slightly with a live torpedo slung underneath. The ailerons were incredibly heavy. They required serious physical effort from the pilot. At low speeds, the roll rate became even more sluggish. On the flip side, the rudder and elevator were light and precise. The catch was that you had to be extremely careful in steep turns or dive recoveries to avoid overstressing the airframe. As airspeed built up, the rudder became overly sensitive. This forced the pilot to constantly chase the trim. In a steep dive, the ailerons locked up almost completely. Using the rudder demanded absolute precision. Any abrupt input triggered violent vibrations and a dangerous wing drop. Dropping the flaps caused a severe nose-up pitching moment. You could try to trim it out, but the elevator trim tabs just didn't have enough authority to keep the workload manageable. The British Firebrand strike fighter was quite a marvel for its time. This was mainly because it was fully capable of complex aerobatics. What is really impressive is that it could fly this envelope even with a heavy, live torpedo on the rack. To pull these maneuvers off safely, pilots had to strictly manage their entry speeds. For example, flying a barrel roll required an entry speed between 180 and 200 knots. A loop meant diving to accelerate to somewhere between 280 and 300 knots. A classic Immelmann required carrying anywhere from 300 to 320 knots. Lieutenant Commander Ivers spectacularly proved to the public just how capable the aircraft was. He flew hard aerobatics with a torpedo on the center line. He put a TF Mark IV through its paces during a thrilling flight demonstration at Heston on October 2, 1945. Of course, flying a routine like that demanded absolute focus. The slightest mistake could kill your lift and snap the aircraft right into a dangerous spin. In a clean configuration, meaning gear and flaps up with no ordnance, and the throttle pulled back to idle, the aircraft would stall at 95 knots. At the brake, the nose would gently drop. This was accompanied by a 10 to 15 degree wing dip. But with the gear and flaps fully deployed, the stall would hit suddenly and violently at just 77 knots. With a torpedo on board, a stall resulted in a vicious nose-down pitch. Things only got worse if the pilot instinctively held back pressure on the stick. Fortunately, stall recovery was surprisingly straightforward. Just cleanly release the back pressure, push the stick forward, and the aircraft would quickly fly itself out. During tight, high G turns, the Firebrand actually gave the pilot plenty of warning before an accelerated stall. The stick forces on the elevator would noticeably slack off. Once you felt that mushiness in the controls, all you had to do was relax the back pressure. The aircraft would obediently and safely fly out of the turn. Landing the airplane, however, required absolute precision. To bring in an empty aircraft with the flaps down, a pilot had to fly the approach at anywhere from 100 to 105 knots. The actual touchdown on the main gear needed to happen right at 90 knots. It was during this phase that one of the Firebrand's biggest flaws showed up. This was the absolutely terrible forward visibility from the cockpit. Because of this massive blind spot, pilots had to fly a curving approach just to keep the runway in sight. Carrier landings also meant coming in on a curve, but this was at a much slower speed of about 80 knots. In those critical seconds, the pilot's eyes had to be glued to the instruments. At speeds that slow, the ailerons were practically useless. A tiny margin of just 3 or 4 knots was all that stood between the pilot and a stall. To make this incredibly stressful task a bit easier, engineers actually mounted a dedicated airspeed indicator outside the cockpit, right in front of the windshield. The landing gear itself was incredibly tough. The Navy never really had any complaints about it. However, when landing on a conventional runway without catching an arresting wire, the rollout felt endless to the pilots. This was the complex but fascinating aircraft. It eventually began filling out the fleet. The very first combat unit to receive the new TF-5 Firebrands was 813 Squadron. Pilots slowly transitioned over to them from their older TF-4 models. They operated from the fleet carriers HMS Illustrious and HMS Implacable. The squadron performed exceptionally well during large-scale exercises. These took place across the Atlantic and the Mediterranean. At the time, they were part of the 1st Carrier Air Group. This group was initially based at RNAS Culdros. Later, it relocated to RNAS Culham. For quite a long time, 813 Squadron remained the only unit flying Firebrands. This was despite the total number of TF-5 aircraft. Both newly built and converted from older TF-4 airframes, they numbered over 100. Most of these strike fighters were just sitting in storage. However, some of these aircraft were put to better use. In December 1950, 3 years after production ended, they were used to equip 827 Squadron. This unit had just returned from the Korean War. There, their pilots had been forced to fly hopelessly outdated Firefly FR-1s. The pilots were thrilled and relieved to transition to these much more capable planes. That being said, this marked the end of any large-scale re-equipping of the fleet air arm with Firebrands. 12 aircraft from 827 Squadron continued their service aboard HMS Illustrious. Between 1952 and 1953, they were even redeployed to the pride of the fleet. This was the largest British carrier at the time, HMS Eagle. But the story of these airplanes was not limited to strict military service. Firebrands became popular fixtures in the air races. These races were common in Britain back then. Flying for the manufacturer at these competitions was the chief test pilot for Blackburn, Peter George Lawrence. He masterfully demonstrated the speed of the strike fighter at the prestigious Air Challenge Cup. For example, in late June 1949, on the course at Sherburn in Elmet, he did not just participate, he took home a spectacular victory. Then, in the summer of 1950, he thrilled the crowds again with his flying at the Elmdon Air Races. This proved once and for all that this heavy military aircraft had a true sporting pedigree. While the Firebrands were kept in reserve, the Royal Navy was still heavily involved in the Korean War. In those brutal battles, British carrier-based Sea Furies and Fireflies were primarily flying ground attack missions. Under those conditions, the massive payload capacity of the Firebrand would have been incredibly useful. Despite this, these heavy strike fighters were never destined to take to the skies over the Pacific. The reason for this was not that the Admiralty lacked faith in the Firebrand. On the contrary, naval brass fully understood the strategic value of the aircraft. During those years, the world was on edge. Everyone was bracing for a Third World War where Western nations would have to face off against the Soviet Union. It was expected that the main Soviet ground assault would hit Western Europe. Meanwhile, their navy would try to sever vital transatlantic supply lines. To defend against the massive Soviet fleet, the British would need their most modern strike aircraft. In the early 50s, the Firebrand was still the primary strike asset of the Royal Navy, so they sent only light carriers with older aircraft to fight in Korea, halfway across the globe. At the same time, they kept their most powerful fleet carriers like HMS Victorious back in home waters. Ultimately, that global war never broke out. The only real chance to test the Firebrand in actual combat was lost forever. These planes never fired a shot in anger, but they remained in service with the fleet air arm right up until 1953. Eventually, they were replaced by a powerful new turboprop torpedo fighter, the Westland Wyvern. Interestingly enough, the fate of the successor largely mirrored the history of the Firebrand itself. The Wyvern also faced a grueling development cycle that dragged on for nearly a decade. It was plagued by constant engine swaps, only to see just 5 short years of active service. It seems that was just the curse of the entire torpedo fighter concept in the Royal Navy. After they were finally retired, the surviving Firebrands met a pretty sad end. They were either scrapped for metal or used as practice targets for crash and rescue drills. As for the airframes lucky enough to escape a fiery end, they found their final resting place at the bottom of the ocean. Along with other obsolete aircraft, they were used as dead weight. They were catapulted straight in the sea to rigorously test the Navy's new steam catapults. It was an inglorious end for an airplane that held an infamous record for its painfully long development cycle. It took 7 long years of constant redesigns and modifications before the aircraft was truly ready for combat. And you have to remember exactly when this was happening. Throughout 5 years of the Second World War, engineers developed 3 experimental variants and built 50 airframes. Yet the Firebrand still completely missed the war. It's honestly amazing that this questionable aircraft ever made it into frontline combat squadrons. The only real way to explain it is with the old saying, if you hammer away at a problem long enough, eventually you'll come up with something. And what they ended up with was exactly that, just something. Of course, you have to give credit to the sheer stubbornness of the British designers. They knew how to get even the most hopeless airframe into working condition. But looking back, you just have to admit the obvious. It probably would have been a whole lot better for everyone if the ambitious B-37 project had stayed nothing more than a sketch on the drawing board.